Okay, so now that we have a good idea what exactly array list is, should be a good time now to actually, solve a bunch of questions related to that as well. The first question is intersection of arrays. What does that mean is, first of all, you would actually be given, you will actually be given two arrays. One array could be 10. So these are arrays which are given. Okay. 10, 19, 20, 23, 40, let's say 23 or 20 rather, 30, 40, 40, 40, 50. Okay. And then there is another array also given to you. You can assume both to be sorted in the input itself, and you basically have to tell the intersection of both the elements, like the elements which are present in both of the arrays. So the output in this case will be 20, 30 and 40. Okay, this is matching with this. This matches with this. Remember, 2 30s cannot match with 130 in the another array. Okay, and you can have this which matches with this, right? And this is what I would say, since we could only find 3 intersections over here, that is why in the output we can say that we only have 3 elements, and you have to present all those elements as an output over here. Okay, and yes, first of all, both the arrays are sorted. Okay, and both the arrays can differ in size, right? The size of both the arrays could be different given in the input. It may be same, it may not be same, but yes, both the arrays given in the input will be completely sorted. Okay, so this is what the problem statement is. I hope this is clear to all of you, and then you can pause for a minute and try to think of its solution. Okay, now we'll take a look at how we can do this. One of the very simple approaches that will come to your mind and you can apply as well, right? For example, there are a bunch of elements over here, 20, 22, and then let's say 16, 20, 22, right? A simple approach that you could apply is take one element from this array, right, 10, and then search 10 in this entire array. Okay, and because 10 is not there, it will not be a part of the output. Okay, then you take 15 as an element, and then in this entire array search for 15, right? Now since 15 is not there, it will not be a part of the output. Now you take this element 20, and in this entire array you search for the element 20. You could find 20, so you keep it in the output. Okay, so this is like, I am for every element of one of the arrays, I am searching the entire other array. Okay, and then let's say for element 22, you entirely search this array again, and you basically do this. Okay, now I think that is one approach that can come to your mind, and along with that, a very good question to understand the use case of array list as well, right? What you will see in this question is that you have been given 2 arrays for which you have to find the intersection for both of them, and very clearly you cannot really say for sure the size of the output array in this, correct? Right? Just by looking at the question, you cannot say whether the output will have 2 elements, 3 elements, all the elements, or 0 elements. Thus, call for the use case where the output should actually be stored in an array list. When you cannot really predict the number of elements beforehand in the output, you tend to use array list in those situations. Okay, that's again a very important point. Now again, like I said, this approach is not very good, and a very big flaw or an observation that you should make while using this approach is this. Let's say I was at this iteration where I was at the element 20, right? And I tried finding the element 20 in this array and it was present over here. Okay, the element 20 was present over here. Now next I have to find the element 22, right? Next, after this, what I have to do is I have to find the element 22, right? Now, don't you think there is a very important property given in the question that both the arrays are sorted? So if I have to find the element 22, right, and 20 was found over here, is there even any point of looking at the elements behind 20? Will 22 ever be behind 20? No, right? But we were still doing that in the brute force approach, right? We were still looking at elements before 20 to be able to find 22, right? A very simple idea was that if you found, let's say, 20 at the 6th index, right? There is no point of looking at all the elements from 0 to 5th index. 22 will not be present over here, right? It always makes sense to look for the element 22 post 20, right? Or the instance or the index where you found 20 after that. And this is the idea we'll actually apply as well. Okay, let's do a quick try run. So what I will do is I will actually take two variables over here. This was 30, 30, 40. Okay, so I will take two variables, I over here, and then I will take j over here. Okay, now I will see that the element at I is 10, at the element of at j is 15, right? So I is pointing at 10 and j is pointing at 15, right? If I really want them to point towards the same element, can I say that I need to move the I pointer towards a larger value? Because if I will move j, I will move farther away from 10, right? If I have to match 10 and 15 and there is no option to move backwards, I have to only move forward. So I should move the I pointer, hoping that after 10, I will find 15. And it is a possibility because both the arrays are sorted. So after 10 only, I will find 15. So in case the value pointed at ith index is less than the jth index, you move the I pointer. Now I is pointing at 19. Now you have to match 19 and 15. Again, it's not possible to match both of them. And if I have to match 15 and 19, the 15 value has to turn into 19, right? And it can if I move forward. So in this case, if the value at jth index is less than the ith index, move the jth index. Now the value over here is 19 and 16. Again, I have to match it to 19. I need to move even forward. Now, I have to match 19 and 17. Again, j has to move forward, right? The value at jth index is less than the ith index. Move j forward. Now, j is pointing at 20 and I is pointing at 19. The value of I is less, so move I forward. Okay. In this case, what you will realize is that they both actually match at this point. Whatever is pointed at I is also pointed at j. So in the output array, create an output array and just add array list, output array list, and add 20 to it, right? And the moment you find a match, both move both the pointers forward together. Like not just one, but both of them will now move. Now I is pointing at 30. J is pointing at 25. Which pointer do you think should move? J, right? So in this case, J should move forward in order to match I, and that is why J will come over here. Now, both of them actually match at this particular point of time. So 30 will be added, and post that, both of them will together move forward. Now I and j do not match. In order for them to match, I will have to move the j pointer over here. And now again, both of them match. So I will come towards the very end. Okay. Now after this, when this happens, move both I and j. I comes over here and j comes over here, right? The moment you reach the end of any one of the array, right, that is the time you stop, right? Because it does not even make sense to have more elements in the first array, right? Even if there are more elements in the first array, I will never find a corresponding match because the ARR2 or the array 2 has basically ended, right? That means there are no elements greater than 40 in ARR2. So even though ARR1 has it, it will never find a match. Okay, so this is how you can actually utilize the power that both the arrays in the input are sorted and make your process a little faster for finding the elements. Okay, and that is how it works. Let's take a quick look at the implementation as well. So over here, take one array. Again, I'm taking the same one. Okay, and I call the this function returns an array list of integer as an output, and it takes an input of two arrays. Okay. First, I will create the answer array list. While I is less than 1 dot length, and you only move forward till the time both have elements in it. Even if one of the arrays ends, you have to stop right in them there. Over here, if the element at the ith index is smaller than the one at the jth index, what do we move? We do I plus plus. Okay. Else if the element at the ith index is bigger and the jth index is smaller, then you move the jth index, right? And the only possible case in the last one is that both of them are pointing to the same and the right element. So in that case, in the answer, just add the element which maybe I or j is pointing to. Just do I plus plus and just do j plus plus. Okay, and in the end, you just return the answer. Let's see if this runs. And you can see in the output, we have 20, 30, and 40, which we were expecting as well, right? Followed the simple and the straight idea, which we were talking about in the dry run as well. And this is how you solve the question, intersection of two arrays.